I am on page 171 and we're looking at number 5. Kellen brings X soccer balls to practice. His coach brings 12 soccer balls to practice. If 2x plus 4 equals the number of balls his coach brought to practice, how many balls did Kellen bring to practice? So we are going to set up this scenario. I'm going to set it up in words first. So Kellen brings some soccer balls to practice, and the coach brings some balls to practice. Now, we are interested in how many Kellen brought. It tells me that the coach brought 12, and it also tells me that 2x plus 4 equals the number the coach brought. So 2x plus 4 equals 12. And we know that Kellen brought X. So I'm going to assume that this X and this X are referring to the same amount. So if I solve this equation for X, I'm going to know what the value of this X would be. So I'm just going to solve this equation for the value of X. And I'm going to do that by moving the 4 to the constant side and canceling. So 8 is equal to 2x, and then divide by 2 and cancel. So the value of x is 4. And that's the same value that Kellen brought. So Kellen brought 4 soccer balls to practice. That's sort of an unusual question. It didn't unfold the way I thought it would, but that's okay. Doesn't have to. All right. Number 1 at the bottom. It says to read each problem and complete the task. A kennel charges an upfront fee of $12. Each day of boarding is $8 for cats and $12 for dogs. Graph the equations, and then we'll answer the questions. So I'm going to need a graph. I'm going to put it down here. I'll tell you what, I'm not going to try to squeeze all that in. Let me just copy this problem and take it to my notebook, because this is going to take a little bit more space than I've got here. So let's jump back over to the functions notebook and put in a new page. And we'll work it right here. I do have to take out what's on this page. I think I'm going to leave the graph because I probably am going to need that. I know I'm going to need one. And we maybe can put both graphs on one. Let's see how that works. And I don't want to... Why is that not... Oh, because I have it turned off. I want to delete those. Okay. So here is the problem that I just copied. And it gives me 2 equations that I need to graph. So we have this equation, which would be the one for cats, and then this one is for dogs. And do I want to graph? We'll see if we can get them both on one plane. If not, we'll just use 2. It doesn't matter. But let me draw my coordinate plane. And they give me an equation that I need to graph. So the first thing I'm going to do is to come up with a table of values. So the formula for the cats would be this one, because cats only cost $8 a day. Why, I don't know, because mine are far more trouble than the dogs are. Maybe they don't eat as much. I don't know. But this is the equation for the cats, and then this is the equation for the dogs, because the dogs cost $12 a day for boarding, plus that flat rate of upfront fee. So I need to come up with two sets of coordinates. And I'm just going to draw this once and copy and paste it. So draw yourself a table for the cats, and then a table for the dogs. And let's do some math. So let's work on the cats first. So I'm going to say this is the X column, this is the Y column, and I'm going to use 1 day, 2 days, and 3 days. So this is also my independent variable. I decide how many days I want to board the animals, and then the Y at the output will be the cost, the total cost. So for 1 day, when X is 1, Y is 8 plus 12, or Y is 20 when X is 1. Then when X is 2, you just put a line to divide these out. When X is 2, Y is 16 plus 12, or $28, because remember it's $8 more each day. So you can even get by on this one without having to do that, but let me go ahead because I'm supposed to. 8 times 3 is 24, plus 12 is $36, another $8. So each time I'm just adding $8 because it's $8 a day. Okay, for the dogs, we're going to do the same thing. So days will be the X's, and I'm going to use the 1, a 2, and a 3. Y will be the total cost. So when X is 1, Y is 24. So for 1 day, your dogs are going to cost you $24. Now you can just add 12 to each of those. Let me do one more and then we'll just add 12. So then for 2 days, Y is going to be $36. So for 3 days, we're going to add another 12 on there. It would be $48 for the dogs. So we've completed the table of values. We can graph at this point. I think I'm going to graph right here because that's the one that's closest to my work. All right. So remember the, and actually let me just do it this way. Let's just look at one quadrant because all these values are positive. I don't need to see a whole plane. I can see it right here on one section of the graph. So the decision that has to be made, the choice that you have is how many days you want to board your pets. And that's an independent variable. You decide how many days. You can do it for 1. You can do it for 2. You can do for as many as you want. And depending on how many days you choose, you will have to pay some money, total cost. And this is ranging anywhere from 20 to 48, given the values that we have. So I'm just going to go by fives, I think, or let's see, let's do it, since all of those are even numbers, let's do it by fours. So 0, I have no idea why all of a sudden it does the eraser. 4, 8, 12, and remember these are dollar amounts, 16, 20, I bet I don't have enough, 24, 28, 32, 36, there would be 40. We can probably get by here. All right, now remember we have two different equations going on. We have the cats and we have the dogs. And I'm going to focus on the cats first. So let's make this yellow. Let me just highlight all of this in yellow so we know that we're dealing with the cats on this one. So I'm going to go ahead and plot some points and graph my cats. So one day costs $20. 2 days costs $28. And 3 days cost $36. So here is the slope, the line for the cats. And that can go on for as many days as you want it to. Obviously, if you have 0 days, you have $0. Okay. So then let's look at the same scenario for the dogs. And I'm going to change colors there and also here for the dogs. Now for a dog, 1 day is going to cost $24. 2 days will cost $36. And 3 days would be somewhere up in here at $48. Whoa, that's not right. This is where I get in trouble. I tell you what, let's see if this will work. I just had a brainstorm. I bet it won't, because usually my brainstorms turn out to be not good things. No, see, there we go. Let's try to move just, there we go. Oh, look at that. We're going to piece that graph on down there, and we'll make this work, by George. Okay, so the scale will continue. Let me go ahead and continue it up this way. And so this would be 44. And this would be 48. And this would be 52 if we needed it. And now I can see what I'm doing. So the third day for the dogs is 48. This is not easy to see, is it? Is that right? Something's not right here. Let me do it this way. Third day, $48. This is what's not right. I've got that second point out of place. The second day is $36. And that needs to be right there because I skipped a line. So the equation for the dogs looks something like this. Both are positive slopes because both are building up. If you're boarding your animals, you're paying more each day. So that would be a positive slope. Let's see if we can do rise over run for these just to get our slopes. I'm going to use green to do that. So the rise on this red line is 1, 2, 4, 5, 6. Whoa, I went by it. Sorry. It's 6 units up and 2 units across. But I want to actually use, instead of the units, I want to actually use the dollar amounts. So 48 minus 36, this is going to be $12. And this is going to be 1 day. Remember, the days are covering 2 boxes. So the slope on this one is 12 over 1. Slope for the dogs. And that makes sense because it's $12 a day. $12 for 1 day. So the slope here is 12. Now for the cats, we are having a rise of 4 units, which represents $8 and 1 day. So it's rise of $8 for a day. So for the cats, the slope is 8, or $8 a day. We already knew that. The dogs cost more, so the slope is greater than that of the cats. And I have completely forgotten what we're doing here. So, what is the cost for boarding a cat for a week? And what is the cost for boarding a dog for a week? Well, for a cat, we can simply plug in our formula. It's this one. A week is 7 days. So let's put X as 7. And the cats are $8 a day. So you have $56 plus 12. So for cats, you would have, $68 for a week. So let's answer that. The cats, $68. And then the dogs would be using this formula of y equals 12 times 7 plus 12. So 12 times 7 is 84, plus another 12 would be $96 a week for the dogs. So we've answered part A of question 1. And then we need to do part B. For how many dogs and how many cats is the total price per day the same? So they're giving me some choices. This is price per day, so we're dealing with the slope. All right. So let's take the slope for the dogs, which was 12. So 2 times 12 plus 3 times, oh, sorry, not plus. We want to know if 2 times the dogs and 3 times the cats are the same amount. Well, 2 12s are 24 and 3 8s are 24. So yes, that is true. 3 dogs and 2 cats. So we have 3 times 12, that's 36, and 16 on the other side. Those do not equal. 2 dogs. We know this can't be right because the prices are different. So if you have 2 of each animal, there's no way that's going to work out to be equal. And then 3 dogs would be 3 12s, and 4 cats would be 4 8s. So we have 36 here and 32 here. It's close, but it's not equal. So the answer we want is this one. If you have $24, you can board 2 dogs, or you can board 3 cats. So why did I do all that? Oh, it said to graph. So that's why I went through all that. I was thinking, did I just want to torment us or what? But it specifically said to graph those. So If I didn't have to graph it, if I were on a test, I wouldn't graph it. But it said to, so we did what it said. All right, I'm going to stop this video. It's getting quite long, and I'll see you in the next one for problem number 2.